What if the biggest breakthrough in nuclear energy wasn't happening in America or Europe, but in a remote desert in northwest China? No press conference, no global headlines, just a quiet test facility in the Gobi Desert, running a reactor unlike almost anything else on Earth. So what exactly is China building out there? And why are nuclear scientists around the world suddenly paying attention? To understand why this matters, we need to start with the reactors we already have. Almost every nuclear power plant on the planet today runs on uranium. Uranium works by splitting atoms apart in a controlled way, releasing enormous amounts of energy. Think of it like a tightly wound spring slowly released to generate heat, which then produces electricity. It's powerful, it's proven, but it's not perfect. Here's the problem. Uranium reactors are incredibly complex to build safely. They require massive containment systems, high-pressure cooling, and constant monitoring, because if something goes wrong, the consequences can be catastrophic. Just the names Chernobyl and Fukushima are enough to make most people uneasy. Then there's the waste. Used uranium fuel remains radioactive for thousands of years. We're literally storing warning labels for future civilizations. And on top of that, uranium reactors only extract a small fraction of the energy available in the fuel. Most of the potential power is simply left unused. So, for decades, scientists have been asking a question. What if there was a different element that could produce nuclear energy with fewer of these problems? That's where thorium enters the story. Thorium is a naturally occurring radioactive element, similar to uranium, but chemically different in how it behaves inside a reactor. It's actually more abundant in the Earth's crust than uranium, and countries like the US, Australia, India, and yes, China, all have significant reserves of it. Here's where things get interesting. Scientists have known about thorium's potential since the 1960s. American researchers at Oak Ridge National Laboratory actually built and successfully tested a thorium reactor decades ago. It worked. So why didn't the world switch to thorium back then? Because thorium reactors don't easily produce material for nuclear weapons, and during the Cold War, that mattered. Uranium and plutonium reactors could serve two purposes at once: energy and weapons production. Thorium couldn't offer that advantage, so funding dried up and the technology was quietly shelved. For nearly 50 years, thorium sat in scientific papers, almost forgotten, until China decided to bring it back. But to understand why thorium is exciting, we first need to understand the reactor China is testing. It's called a molten salt reactor. Instead of using solid fuel rods like traditional reactors, a molten salt reactor dissolves nuclear fuel into a liquid salt mixture heated to extremely high temperatures. Imagine replacing solid ice cubes with a flowing, glowing liquid, one that carries heat far more efficiently. This liquid fuel flows through the system, generating heat, which is then used to produce electricity. Why does that matter? Because this design allows for something remarkable. If something goes wrong, the liquid fuel can automatically drain into a separate containment tank and cool down safely, without human intervention or complex emergency systems. In theory, that makes meltdown scenarios far less likely. So why is China investing so heavily in this? Part of it is energy security. China has massive thorium reserves, and reducing dependence on imported uranium strengthens their long-term energy independence. Part of it is climate strategy. China is aggressively pursuing carbon reduction, and nuclear energy, without the greenhouse gas emissions of fossil fuels, fits perfectly into that plan. But there's something bigger happening too. Technological leadership. Whoever masters this technology first could shape the next generation of global nuclear power, exporting reactors, patents, and influence for decades to come. China isn't just testing a reactor, they're positioning themselves to lead an entire industry. So what are the real potential benefits? If thorium molten salt technology succeeds at scale, it could offer more efficient fuel use, meaning less mined material for the same amount of energy. It could produce significantly less long-lived radioactive waste, and its design may reduce the risk of certain types of accidents. That sounds incredible, but here's the twist. Thorium is not a miracle solution, not yet. Molten salt reactors involve extremely corrosive, extremely hot liquid salt, and finding materials that can safely contain that environment for decades is still a massive engineering challenge. Scaling a small experimental reactor into a full commercial power plant is enormously difficult and expensive. There are also serious questions about long-term reliability, safety certification, and cost competitiveness compared to today's uranium reactors, which already have decades of infrastructure, regulation, and global supply chains behind them. That's why, despite the excitement, uranium reactors still generate the overwhelming majority of nuclear power worldwide, and they likely will for a long time. So, is China's thorium reactor the future of energy, or an ambitious experiment that may never scale beyond the lab? The honest answer is, we don't know yet. Many nuclear experts believe the next 10 years will be critical. If China can solve the material and engineering challenges, thorium molten salt reactors could become one of the most important energy breakthroughs of this century. But if the obstacles prove too difficult, it may join a long list of promising technologies that worked in theory but never made it into the real world. Either way, one thing is clear. The race to reinvent nuclear energy has already begun, and the decisions made in a quiet desert facility today may quietly shape how the entire world powers itself tomorrow.